anyways, let's get started. So the first thing, this should mostly be review. If it's not, that's completely fine. If you guys want to take notes on anything and I go too fast, I am recording. I will hopefully have this all recorded so you can go back and get notes on something. So the first thing we're going to go over is slope-intercept form. The equation you'll see this in is y equals mx plus b. This is a big part of the SAT. You'll see this in so many of the problems. I would say probably at least 10% of the problems will have an equation that is in slope-intercept form or close to slope-intercept form, and it wants you to solve for it. So, what does each of these variables mean? B is the y-intercept. In problems with context, this is what you start with. If you have a graph here, let me go into Desmos. Let's say you have a graph that's y equals 7x plus 49. I obviously can't see that in the graph right now, but let me zoom out. 49 is going to be my y-intercept. As long as it's in this form, your y-intercept is going to be your b. And yeah, zoom in, zoom out on Desmos. You're going to need to use that tool a lot, so make sure you know how to do that. And then, like I said, in problems with context, it's going to be what you start with. Let's say there was a problem with this equation. Jill started with 49 apples. She gained 7 apples per day. The slope is going to be 7 because each time x goes up by 1, the y goes up by 7, which leads me to the slope. The slope is going to go down if it's negative. So if I did negative 7x instead, the line would be going down as x increases, and if it was positive, the y would be going up as x increases. That's pretty important to know because in some problems it might ask you in context if we're losing something or if we're gaining something. So definitely keep that in mind. So in a problem with context, what would this look like? So we're going to do a slope equation first. Given the equation represents the distance d in inches, where t represents the number of seconds since an object started moving, which of the following is the best interpretation of 16 in this context? So if we go into Desmos, just to look, what was it? D equals 16t. I always like to exchange the d for y and t for x because t is obviously going to be your x here because it's a time interval, number of seconds. Usually the time is going to go on the x-intercept. And y is just going to be your d, the distance it travels. So as we can see, when x increases by 1, let's say x equals 1, x starts at 0, 0. And when it increases by 1, it goes up 16. So in context, that would mean an increase in 16 for every 1 second, because t is represented in seconds, and 16 is what it's being multiplied every time it goes a second. So if you went from 1 to 2 seconds, you'd go from 16 to 32, and etc. further on. So an object moved a total of 16 inches. That's obviously not right because the object can keep going for as long as possible with the equation. An object moved a total of 16t inches. That isn't right either because t is a variable here. T is not a constant, so you can't just say that it moved a variable amount of inches. The object is moving at a rate of 16 inches per second. So for every second it increases 16 inches, that would be your correct answer choice. And then 1/16, that would look like this, which it is not doing that based off the equation. So that's one way you might see a slope be interpreted on the SAT. So the y-intercept. This is a problem for the y-intercept. Let's go over this one. The function gives the estimated height in feet of a willow tree x years after its height was first measured. Which statement is the best interpretation of 4 in this context? So, as we said originally, B is what you start with. So let's type this equation into Desmos. You don't have to at all. I recommend you do not type these equations into Desmos when you're on the SAT. That is just a waste of time, but I'm just showing you guys what each line would look like typed into Desmos. So, the tree will be measured each year for 4 years. B in context problems is what you begin with, so that's not correct. You want to just look for the answer choice that's talking about what you begin with. Is estimated to grow maximum height of 4 feet. That's not true. The estimated height of the tree increases by 4 feet per year. If 4 was in the M, the slope area in front of X, this would be your correct answer, but since it's B, the estimated height of a tree was 4 feet when it was first measured. First measured of a willow tree X years after its height was first measured, so the beginning would be when it was first measured, so it would be answer choice D. And then this is another practice problem for slope. This one's a little bit harder. It gives you the graph f of x equals 11. So let's call the graph instead of y. I always like to replace y with something. Since we already have f of x in the problem, let's use g of x. Y equals f of x minus 11. So let's type in each of f of x. F of x equals negative 13x minus 11 equals negative 13x minus 11. G is going to be your, I would honestly just turn f of x off because you're looking at G. You can see that this has so much bigger of a slope than what the graph is showing, so A is not your correct answer. Let's do negative 2x plus 7. This looks correct. You're at 2, 0, and you're at 0, negative 4. If you have two problems like that in the linear equation, yes, this is 0, negative 4, you can automatically click that point. As long as you have 2 points with the linear equation, you can find the slope, the y-intercept, everything, no matter what. 2 points is all you need. One second. I think I got a message. I might email someone to get in. Okay. Let me do something real quick, and then I will be right back. Sorry about that. This is taking a second longer than I wanted it to. go. Okay. Next, we're going to go over quadratic equations and vertex formula. This is another kind of important one you want to know. You want to know what a quadratic equation looks like because we're going to go over tables later. And once we get into tables, it's really important to know what a quadratic equation looks like because you want to know what type of a regression you're going to be using. So the standard equation of a quadratic is y equals ax squared plus bx plus c. We'll talk about what some of the variables mean later. And to find the vertex for this, because finding the vertex is going to be the most important thing for the SAT for the most part when you're doing quadratic equations. So you would just plug the equation into Desmos. Say I had like 5x squared plus 4x plus c, and I'll show you guys what a vertex looks like right now. Let's say f of x equaled 5x squared plus 4x plus 3. This is your vertex. It's going to be that little endpoint right here. And a lot of equations are going to ask you to find the vertex. So make sure you know what the vertex is. And pretty much for those equations that will ask you to find the vertex, they might ask you to do one more thing. Like an equation might say, the x value of a vertex is equal to c. What is c plus 5? So the x value of this vertex is negative 0.4. So you would just plug in negative, let's say c plus 5, and then we know since the x value of the vertex is c, c would just equal negative 0.4. And then it would give you the answer to this equation, which would be 4.6. Vertex form, a times x minus h squared plus k. This is a bit more important of a form to know, because this will save you so much time if you know how to use it. A lot of the times they'll have an equation in this form, and they will ask you to find the vertex of the equation. Find the vertex, you could plug it into Desmos, or you could use h and k. So let's just put an equation with this form. Y equals 5 times x minus 3, and then that whole thing squared, plus 8. Let's get rid of these. This is in this form. The vertex for this is 3, 8. So h is basically going to be your x value. X minus h, so if it's a negative 3 in here, your x value, your vertex is going to be positive 3. If k is positive 8, your y value for your vertex is going to be positive 8. So if you had this equation right here, you don't need the graph. If it asks you for the vertex, you would know h is negative 3, or h is 3. So your x value is 3 and k is 8. So your y value is 8. That is so much quicker than plugging it into Desmos. And although you can do it while plugging into Desmos, I recommend remembering that, because from all the SATs I've taken, there's been one problem like that at least for each test. So good time saver. And what is the vertex of a quadratic equation? We've went over it a little bit here. This is some important information about them. So your vertex is always going to be your maximum or minimum. For a quadratic equation, it is always the maximum or minimum. There is never a case where it's not. So if it is asking you for the minimum of an equation, it is asking you for the vertex of that equation if it's a quadratic equation. So if you have vertex form, like I said earlier on, you can use that to find h and k. which gives you your equation. And at the bottom here, I have hk because h is your x value, k is your y value. That's why I have it looking like this, because that's going to be what your coordinate looks like. And now let's talk about a. So when a is negative in either of these equations, the vertex or the graph will open down. Say I set this negative, the graph will open downwards, meaning it's going to look like an N or an arch. So a being negative means the graph opens down, and it would ask you to find a maximum if it gave you this equation. There is no minimum to this equation because x literally goes to infinity, or negative infinity for both sides. A being positive means the vertex or the graph itself opens up, so it will look like a U. And again, it's only going to ask you for the minimum. The graph opens up to infinity, so there is no maximum for this graph. And then h is the x coordinate, k is the y coordinate. And this is a practice problem for standard form and vertex form. So this one asks for the minimum value of the given equation. So now I know we are looking for the vertex. So I'm going to plug this equation into Desmos and find the vertex, because it's in standard form, not vertex form. So this would be x squared minus 48x plus 2304, I believe. Yep, okay. So we're at the center part. We don't see an equation. You can zoom out to try to look for your equation two different ways. You can use I have a mouse currently, but you'll have a mouse pad when you use your laptop on the SAT. You can use that to zoom out. Or what's quicker when you know you're gonna have to zoom out far because of this 2000, I like to use this minus button and I get out quick. So you can see this is the vertex. So I click on this, and the x value is 24, the y value is 1728. So what is the minimum value of the given function? It's asking for the y value because it's minimum, so it would be y equals 1728. What you would type in is just 1728. So for vertex form of a quadratic, the function f is given by the given equation. For what value does f of x reaches minimum? For what value x does f of x reaches minimum? So one thing you want to look at for this equation is it's asking the value of x, f of x reaches its minimum. So you're still looking for the vertex because you see minimum, but you're looking for the x value of the vertex to answer this. And let me write out this equation. F of x equals x plus 7 squared plus 4. And then the standard equation is y equals a times x minus h squared plus k. So since the 7 is positive here, it is x minus negative 7. That's what it would look like in the original equation, because you have to plug in a negative 7 to get a positive here. So since h is negative 7, the x coordinate of your function is going to be negative 7. The thank you. The y coordinate is going to be positive 4 because it's plus k, and the 4 is positive, so your y coordinate is going to be positive 4. The problem is asking for what value of x does f of x reach its minimum. We know the vertex is negative 7, 4, so the value x would be negative 7. Here, I'll show this on Desmos so you guys can see how this looks. X plus 7 squared plus 4. Go back to the home part. The vertex would be negative 7, 4. Vertex form is nice. Whenever I see a vertex form problem, it's just 10 seconds and then we're good. If I'm going too fast or if there are any questions about any of these problems, just let me know. So next we're going to go over solutions. We've kind of looked at them a little bit, but we've never actually talked about what a solution is. This is a very common term on the SAT. You need to know what a solution is because a lot of questions will ask you, what is a solution to this equation? So a solution is where an equation crosses the x-axis. If I had y equals x plus 2, the equation crosses the x-axis at x equals negative 2. So the solution to the equation would just be negative 2. There are many different ways you can see a solution. I said the solution here is negative 2. You could see it as x equals negative 2 as well. Problem might write a solution to an equation is x equals negative 2. So it's basically giving you a point to that equation. Because a solution, y is always going to be 0. So if a solution is x equals negative 2, one of the points to your equation are going to be negative 2, 0. And what is a solution in a system of equations? This is something we have to know the difference between. When you have one equation, the solution is where the equation crosses the x-axis, like in this problem. But when you have two equations, like y equals negative 5x plus 20, the solution is where the two lines collide. So the solution here would be 3, 5. This is a big difference that you need to understand going into the SAT, because you might think there's two solutions, negative 2, 0, and 4, 0, but the actual solution to a system of equations is where they cross, which will be 3, 5. So this is a solution practice problem. I see this equation. I see no obvious way to tell where it's going to cross the x-axis, so I'm just going to plug this into Desmos. And how I do it is whatever is in the numerator, I make sure to completely have in brackets like that, so when I go to divide, it just puts it over everything. I believe the last part was x plus 9. Let me check that. Yes. And then you set this equal to 7. And then sometimes a solution is going to look like this. And this basically is just giving you the x coordinate to the solution, since you don't need the y coordinate because the solution is 0. This crosses 16. If you're confused, because this looks confusing, like you cannot tell what the solution is when you do this. Just put in the equation y equals 0, and it's going to give you where these cross. It's actually not right now. But you can see this is crossing at exactly 16. So a solution to this equation would be C, 16. If 3x squared minus 18x minus 15 is 0, what is the value of x squared minus 6x? So they're setting this equal to 0, and they want to find the value of x squared minus 6x. So once we plug this in, we'll be able to find the solution, which is what x equals when y equals 0. 3x squared minus 18x minus 15. X squared minus 6. I'll type that in a second. Did I type this in right? Yes, I did. Sometimes questions on the SAT will come out with crazy numbers like this, so you just have to roll with it. So you have x squared minus 6x. I always just put parentheses around what I know I'm going to plug into. So this would be x squared minus 6x. X equals 6.74166. And it comes out as 5.000019556. If it's this close to a whole number, just round it to 5. It wants you to put in 5 as an answer to the equation. And it doesn't say the solution has to be positive or negative, so you could also use this solution in this problem. And you could put in 2 completely different answers, and they would both be right. We're going to start going over Desmos now. This is going to be your most important tool on the SAT. A lot of people say you can do more than 50% of Desmos with, or 50% of the SAT with Desmos. I personally, when I've taken the SAT a lot, I haven't used Desmos too often, but I could have definitely used it more, and it would have improved my score quicker than I did. I never bothered learning Desmos, and that was a bit of a mistake. So, what we're going to go over today is we're going to go over how to plug in mean and median and do mean and median problems with Desmos. We're going to do system of equations problem with Desmos and tables. I've already shown you a system of equation problem with Desmos, but we're going to go over a few more. I believe there's a few harder ones that we're going to go over. 1 second here. Wait, can you go over what the numbers from the last problem? What exactly do you want me to go over here? What they mean? Oh, where did I get the decimal to input? 1 second. So, do you see these 2 big vertical lines? So this is this equation, and you get 2x values. I always go with the positive one if it's asking for one thing, but you could go with either one. Basically, it says this equals 0, so it's asking you to find the x value of this, and then it's asking you to plug in x to x squared minus 6x. So the x value solutions are 6.74 and 0.74166. And so that's how I know how to plug them into x squared minus 6x. Because it's giving me what x equals based off the solution. Does that make sense? Is there anything else you were asking? Did I answer the wrong thing? Okay. Sorry if that was confusing at first. So, Desmos stuff. First, we're going to go over mean and median. So, there really isn't too much to explain about mean and median. Mean is the average of a data set. Median is the middle number of a data set. And finding mean and median is the easiest thing ever with Desmos. There are some hard problems that you can't use mean and median for. I believe I included one in here. But for the most part, mean and median problems are easy. So what is the median of the data set shown? What you would do here is literally go to Desmos, type in median, parentheses, and then type in the numbers to the equation. 73, 74, you would be able to see the equation and Desmos at the same time. So you could do this faster on test day. Also, if it's a smaller data set like this, I personally wouldn't type this into Desmos, especially if it's ordered like this one is, because you can just find the middle number by crossing one off by the sides at a time, and that is so much easier way to do it, or so much quicker in my opinion. The less ordered and bigger the data set is, the better it is to do. 8591. So the median of this data set would be 79. Does this make sense how you type in median? It's median parentheses 0.1 comma 0.2 comma 0.3 and then end once you're finished. And then mean is a little bit harder to do on paper, so most of these I would type into Desmos for mean. This one I wouldn't type into Desmos, but we're going to go over it using Desmos first, and then afterwards I'll show you why I wouldn't do Desmos. So since you have two different data sets and it's asking you to compare the means of the data sets, you're going to want to find the means of both of them. So mean of data set 1, which is 59913, and then mean of data set 2, which is 5991327. 5991327. So the mean of data set 2 is greater than the mean of data set 1. The mean of data set X is greater than the mean of data set Y. This is wrong because data set X is the first data set. So that cannot be correct. The mean of data set X is actually less than the mean of data set Y, which is what it says in answer choice B. At this point, I would click B and move on, but let's go over the rest of the answer choices. The mean of data set X and data set Y are equal. That is obviously not true. When we plugged it into Desmos, they're different. And then D says there's not enough information to compare the means. That's not true because we have both of the means. So, sorry. I would not plug these into Desmos because if you look at these two data sets, data set Y only has one more number than data set X. Otherwise, the data sets are perfectly the same. So since data set Y has an integer that just increases its maximum, you'll know that the mean of data set Y is higher. Because if data set Y was just 59913, it would be the same, it would have the same mean as data set X. But since you add that 27 on, it would have a larger mean than data set X because 27 is going to be bigger than the mean for both of the equations. Same thing, say, I'm going to write this down. Say data set X was 59913 and data set Y was 3599913. These are the same. These would cancel each other out. These means are the same. Since there's a 3 right here, it's going to lower the mean of dataset Y, which would mean dataset Y's mean in this case is actually smaller. So, with certain mean problems, don't type them into Desmos. It's not worth it. Look at the mean problem first. See if you can easily do it in your head. If you can't, then you go to Desmos. Okay. Next. Dataset A consists of 10 positive integers less than 60. The list shown gives 9 of the integers from dataset A. The mean of these 9 integers is 42. If the mean of dataset A is an integer that is greater than 42, what is the value of the largest integer from dataset A? This is a really hard equation. So what we know is dataset A consists of 10 positive integers, and they are all less than 60. And the list is 9 of those integers. In the mean of these 9 integers, mean of 9 integers int equals 42. And the mean of dataset A is a total, so those 9 integers plus the next number, plus n, we'll call it n, is an integer that is greater than 42. So what an integer is, we need to know what an integer is to know how to solve this problem. An integer is a whole number, like 42, 43, 44, 45. So it's not going to be 42.5 or 42.5. Sorry, that looks a little messy. It's not going to be a fraction or a decimal. It's got to be a whole number. An integer is a whole number. So, since we know the mean of dataset A is an integer that is greater than 42. So it could be 43, 44, 45, and beyond. What is the value of the largest integer from dataset A? So, we know dataset A has positive integers less than 60. So n has to be less than 60. What I'm doing here now is, since it's asking for the largest integer from dataset A, I'm putting mean and then the numbers 43, 45, 44, 43, 43, 45, 44, 43, 38, 39, 40, 46, 38, 39, 40, 46, and then 40. So the mean is currently 40.8889. So let's add an integer. We called it n earlier. Let's stick to what we had. So we have n in our equation now. It's going to show this little caution sign because it doesn't know what n equals. So I'm going to put n equals 60. Because in the equation, it has to be, it's 10 positive integers less than 60. So the max it could actually be is 59. So let's put in n equals 59. Now we can see what the mean does here. We need the mean to be an integer because it says the mean of dataset A is an integer. So the whole dataset, the mean has to be an integer. And it wants what the value of the largest integer is from dataset A. So we just keep going down until this mean shows an integer. So it's 58, 57, 56, 55, 54, 53, 52. So n equals 52 gives you the largest integer of the data set, which is 42, because it wants to get the maximum integer mean of the data set. And the highest number you can get, which would give you an integer mean, is n equals 52. This is a super confusing problem, so if anybody has any questions on it, let me know. Whoops. Why did you put 59 instead of 60? So, it says dataset A consists of 10 positive integers less than 60. So, that means n has to be less than 60. If n is less than 60, n cannot include 60. If it was less than or equal to 60, n would be able to include 60. But it's only less than 60, which means it does not include 60. You don't understand what the actual problem is asking. Yeah, this problem, it asks the question in a weird way. It wants to know what the value of the largest integer from dataset A is. So let's rephrase this. What is the largest integer from data set A? And then it says if the mean is of data set A is an integer that is greater than 42. So given, we don't need this common, because it says if the mean, so this is a given type question. Given the mean of the data set is larger than 42. So if the mean of the data set is larger than 42, what is the largest integer from the data set? And the data set has to be less than 60, and the mean has to be an integer. That is the best way you can rephrase that question, in my opinion. What is the largest integer from dataset A given the mean of the dataset is larger than 42? Is there any specific part of the question you don't understand that I can go over? Or is it just like you don't understand what the problem is asking in general? Okay, perfect. Do you want me to go over how I did it again? Because if you didn't understand the question at first, it might be confusing, all that work I just thrown at you. Because we should have a bit of extra time after this meeting. I didn't really know how much time this PowerPoint would take it up. Okay, I'll go over it again. So now that we're given this information, we want to find what the largest integer from dataset A is. So I'm going to keep this mean stuff typed in. So here's the mean of the current dataset. These are the 9 integers from dataset A. So we have to find a how do I phrase this? We have to find an integer that makes the mean of dataset A an integer that is greater than 42. So we would start at 59. Do you get that part? We're trying to find an integer that's less than 60 because it says it consists of 10 positive integers less than 60. Wait, it says the mean of these 9 integers is 42. Did I miss an integer? 43, 45, 44. Oh, this says 33. Okay, this is supposed to be 43. 1 second, that changes the problem. Okay, the mean of the 9 integers is 42. Now we're on the right track here. Is there? Okay. So as we can see in Desmos, the mean of these 9 integers is 42. We want to find the mean of the data set, and we want it to be an integer that is greater than 42. So we would start at the first positive integer less than 60, which is 59. If you want to type your guys' questions in chat, just let me know. Wait, I think you have to text me to do your question. Isabel. You didn't see where I put input n for the equation. Yeah, I'll show you where I put input n now. So I have the mean of these 9 integers, and I want to find the last integer, which I called the last integer n. So it's going to go at the end, and then I'm going to have that last parenthesis after that, because that's the last integer I need to find. Do you see that part? Where I put n here? Okay. So now that I have n, I want to start by plugging in integers that are less than 60. So I would just put n equals, you know the mean of the data set is greater than 42. So in the mean of this data set is already 42, so you could honestly add a slider to n. The minimum it's going to be is 42, and the maximum it can be is 59. And then step, this means for every point you go, so the step would be 1. So then I could just slide this around until I get the next integer, and then n would equal 52. I kind of went fast right there. Sorry. Let me explain this part a little better. I want to find n, and I want to find where the mean of the data set is an integer that is greater than 42. I know n has to be less than 60. That's where I got my upper bound. And I know n has to be greater than 42, because the mean is already 42, and it's got to be greater than that. So that's where my lower bound is. So there's only going to be one integer on this equation if I use the slider. There will be 2 at 42, but it's got to be an integer greater than 42. So the only n value that makes the mean an integer that's greater than 42 between these numbers is n equals 52. So that's how I get n equals 52, and n equals 52 would be the solution to this problem. Yes, Belle, you have your hand up. Do you have a question? Oh, okay. Can you put your hand down yourself? I can lower it for you. Okay. Alright. Next. So now we're going to go over systems of equations using Desmos. We did that earlier when I was describing different types of solutions. You will see I put in 2 linear equations, and I showed you guys how you might see them as a solution, which would just be the where the 2 equations cross. So these type of problems, they will typically ask for a solution to the system of equations. So you would plug in the 2 system of equations, and then you would find where they cross, and that would be your solution. The solution, they're usually going to ask for the x value. So if they don't specify, assume it's saying x value always. And sometimes it might go an extra step. Like I said earlier, it might say a solution to the equation is xy, find x plus 5. Kind of like in this equation earlier. They gave you a solution to the equation, and they asked you to find a different equation based off of that solution. So that can happen in a system of equations as well. So you would plug both equations into Desmos, like I have them plugged in here, and then the intersection is your solution. If you have multiple solutions, you might have a negative and a positive solutions in some questions. It might ask for, like, it might ask, what is the positive solution to this equation? So then you would click whichever one you see as positive, and that would be your solution. It's always going to be talking about the x value. The positive solution is going to be positive on the x value. It might have a negative y value, though. A lot of these questions have context, and what they're asking for is very based on the context. If it's time, it never goes before 0. That's an important thing to know. Like, you would only see this. You would see further on the thing, but it can't go before 0. So we'll hop into some practice problems for this. Y minus 9x equals 13. Y minus 9x equals 13. And then 5x equals 2y. So we can already see they're going to intersect right here. They're not going to intersect elsewhere no matter how far you zoom out. They intersect at -2, -5. So a solution to the system of equations would be -2, -5. Which of the following systems of linear equations has no solution? So I'm going to plug these into Desmos first and show you how they have no solution, but then I'm going to explain why this problem, if you understand this problem on a higher level, you will not need to use Desmos, and this problem will take 2 seconds. So let's plug each in. Let's plug in A. Y equals 6x plus 3, y equals 6x plus 9. And then y equals 6x plus 9. So these never cross. It would show you some type of thing if these ever crossed. It doesn't show you any gray thing. They are always this far apart from each other. So this would be your equation with no solution. So the solution is where if it all they yeah, it's where they meet or collide. It's where two equations meet or collide. Since these equations never collide, there's no solution to this system. So your answer choice would be A. Let's look at the other ones just to get an understanding of them. Y equals 10 and y equals 10x plus 10. These collide right here. This blue line and this line collide right at 0, 10. So this equation has a solution. Y equals 14x plus 14, y equals 10x plus 14. These equations collide right here. You can see right there. So at 0, 14, they have a solution. X equals 3, y equals 10. X equals 3, y equals 10. These two graphs collide right here. So they have a solution right there. So it's definitely A. And in this certain problem, if you remember this, you will not use Desmos. And I just spent a minute to 2 minutes just plugging equations. You will literally save a minute like this if it was answer choice D. So we went over the slope of the equation earlier. The slope of the equation is m in, a lot of these are in the form y equals mx plus b. If the slope of the equations are the same and the b is different, then they will never collide. Since these slopes are the same and their b is different, they'll never touch each other because y equals 6x plus 3, y equals 6x plus 9. The slope is literally how much they move per x value. So this one starts at 0, 9, and then it goes to 115. For every 1 it goes over, it goes 6 up. That's what the slope describes. This one 0, 3, and then it would be 1, 9. So, basically, if they have the same slope and they have different y-intercepts, they can never collide. So I automatically see same slope, different y-intercepts as soon as I go into this problem. Bang, this is a 10-second problem once you know that. Is there any questions about how I did that without Desmos? I might have explained that a little badly. Okay, I'll move on. If I see any questions, I'll go back to that one. One of the two equations in a system of linear equations is given. The system has no solution. Which equation could be the second equation in the system? Okay, so let's plug in 3x equals 36y minus 45. We know this is one of the equations in the system. So we want to find the second equation that makes this system have no solutions. So we want to find an equation that will never cross this equation. So let's plug in x equals 4y. These obviously collide right here, so this equation has a solution. So x equals 4y is not your answer. 1/3 x equals 4y. X equals 4y. I don't see any gray dots to click on, so that means they are always going to be that same amount apart. So this could trick you. Sometimes it'll have something that has such a similar slope that it looks like they'll never collide, but they do collide. So always make sure to zoom out and zoom in somewhere else and check if they're like the same amount far away. Because it's kind of scary, because sometimes the SAT likes to trip you up in that way. And then you have x equals 12y minus 15. We know this is the answer, but let's look at these other ones. X equals 12y minus 15. This equation is on top of this equation. That means it has infinite solutions. If you guys can see, when I click on this, the green line covers the black line completely. Like, no matter how close I get, the green line is right on top of that line. So this one has infinite solutions. Since it's always crossing, it has infinite solutions. 1/3 x equals 12y minus 15. I could just put 1/3 right here. And this one connects right here, so this one definitely has a solution. So the answer would be B. Okay, now we're going to go over tables. Tables are a little bit confusing. They can be used for most types of table problems. There are certain questions that do ask you to analyze a table. In those questions, you cannot just plug in the table to analyze. You're usually going to use tables when it's asking you to find an equation to a table or find a certain point with the table. Do not use these for inequalities. Inequalities, you will not get the inequality equation for a table. So if here, an inequality is, let me show you guys what an inequality is. An inequality would be like y is less than 8x plus 2. It doesn't have the equal sign. It will either have a less than sign, a less than or equal to sign, a greater than sign, or a greater than or equal to sign. If you guys see this inequality right here and you see a table problem, it's most likely going to have you plug in numbers to see if they fit that table. Wow, it's been going for an hour and 24 minutes and it hasn't kicked me out yet. Nice. For anybody who arrived after I said it, I'm expecting technical difficulties today because I have like the free version of Teams and it said it was not going to treat me nicely. So with tables, you can find equations using this. I'll show you guys how to find equations with our practice problem. So we have this practice problem. Let's read the problem before we plug in. The table shows 4 values of x and their corresponding values of f of x. There is a linear relationship between x and f of x that is defined by the equation f of x equals mx minus 28, where m is a constant. What is the value of m? So with linear equations, like I said, we only need 2 points, but for time's sake, I would usually only plug in 2 points. I'll plug in all 4 points for this. So it's going to be 10, 15, 20, 25, and then 82, 137, 82, 137, 192, I believe, and then 247. So you have your points and nothing pops up. You will go to this button here that says add regression, and then you click it. You'll have a thing that pops up saying linear regression. Well, this definitely says there's a linear relationship, so you would use linear regression. And then it gives you that answer right here. It says y equals 10x minus 28. 22 is incorrect. Oh, I typed this in wrong. This is supposed to be 137. There we go. Always double check your answers, because sometimes you type something in wrong, like I did on this problem and that mean problem, and it caused everything to go haywire. But anyways, now we have the correct equation. It's y equals 11x minus 28. This is mx minus b form, just like it is in here. F of x equals mx minus 28, where m is a constant. What is the value of m? It shows you m right here. M would be 11. Practice problem 2. For the linear function f, the table shows 3 values of x and their corresponding values of f of x. Function f is defined by f of x equals x plus b, where a and b are constants. What is the value of a minus b? This is going to be a bit of a harder problem. First, you want to plug in the graph to find the equation. Add a table. It said 1, 0, and negative 1. Oh, 1, 2, and 3. Sorry. What's up, Blue? Why did you put the line as line regression? Here, let me go back to that. So I put this as linear regression because linear regression will give you a linear function, and it says it has a linear relationship in the last problem. If it said it had a quadratic relationship, I would use quadratic regression, and then it gives me the function as a quadratic function. If it said the relationship was exponential, then I would click exponential regression, and it would give me an exponential equation for the function. So that is why I use linear regression, because it shows that it's going to be a linear function. So back to this question. Let's go to the table. It's going to be 1, 2, 3. And then y1's negative 64, 0, 64. 0, 64. So now I'm going to click add regression. It shows f of x equals x plus b. That's in your linear form. Instead of m, they use a, and they also use b here. So we know it's going to be a linear regression. It gives you the equation y equals 64x minus 28. Just in case you can't see what the y-intercept is going to be. Y-intercept is always b, and b is negative 128, so it's going to be 128. But you can always zoom in on the line and see where it crosses the y-axis, and it's at 0, negative 128. So, it says where a and b are constants. B is your y-intercept. A is your slope here. So it's showing you this. It says x plus b in the equation. So we know b, since it's minus, b is equal to negative 128. And then a is equal to 64. So now it wants to know what the value of a minus b is. So 64 minus negative 128 is really 64 plus 128, which would be 192. You can plug that into Desmos if you need to. Does everybody understand this question? It's asking for a minus b, and it shows it's in the equation. That's how I knew to find the equation. Okay. Practice problem 3. The table shows two values of x and their corresponding values of y. In the xy plane, the graph of the linear equation representing this relationship passes through the point 17a. What is the value of a? So it gives us two values, and it says it's a linear equation. So we can just go into here, and we can make a table. Put in these two values, negative 18, negative 48. And then 752. And then once we add a regression and put in linear regression, because the problem says linear equation, then we can solve for what 17a is. So there's a few ways you could do this. First, you could type out the equation. I think if you click this book thing, it puts it out for you. Yeah, if you click the book, it puts it out for you. So it says the relationship passes through the point 17a. 1/7 is the x. So if you plug in 1/7 for x times 1/7, it'll give you the a value, because the a is in the y spot. 1/7 a. This is really just x, y. So if you plug in x, which is 1/7, it'll give you y. So a should be equal to 24.5714. These are in fractional form. So we need to divide all these over so we can see what it is. We know it's not going to be negative 4/11 because our answer isn't negative. We know it's not going to be negative 4/77 because our answer isn't negative. I'll plug in 4/7 to see what I get. 4/7 is 0.57. So let's plug in 172/7. And 172/7 is 24.57. It matches up perfectly. So A is equal to 172/7, which is D. This is also kind of a bit of a harder question, so if anybody just doesn't get this, just let me know and I will go over it again wherever you guys are confused. So, this isn't directly a table problem. It shows up as if it's not a table problem, but it is. Because it gives you 2 points, 0, 2, and 834, and it says it's a linear function. That's all you need to put into a table and make an equation. This is xy, and this is xy. And then it asks which equation defines f where y equals f of x. So, we can use this as a table. The first point is 0, 2. The second point is 834. So we have these two, add or regression. It says it's a linear function. That's how we know to use linear regression again. So y is going to equal 4x plus 2. They exchange y for f of x. They say y equals f of x right here. So f of x equals 4x plus 2. Your answer would be D. Or C, sorry. Did not crop this one very well. For the linear function, f b is a constant when x equals 0, f of x equals 30. What is the value of b? This is not a table function. I don't know why I added this on the end here, but let's go through this just because. F of x equals a plus b. When x equals 0, f of x equals 30. So, f of x equals a plus b when x equals 0, f of x equals 30. So we just plug in 0 for x and 30 for f of x because it gives us that point. 30 equals 0 plus b. This 0 is non-existent because it's 0, so b would equal 30, which it would be D. I don't know why I added that one on the end here, but we'll go over it just because it's there. And that is the end of the slideshow. This one, now I know to make them a bit longer next time. This one was about an hour and 10 minutes. I could have definitely went over more. So, I have a question sheet that I'm going to, I think I'm going to email it out to everybody. So, if you guys want to take like a 10-minute break so I can get those emails out, and y'all want to like go get some water or food or something, I'll email that out. You guys are welcome to stay, welcome to leave if you want to, but these practice questions are going to be really good for you. So, I really recommend staying, going over the practice questions. If anybody has any questions on the practice questions, I will go over the questions on screen.